This video covers the second lesson in Decision 1 minimum connector problems. We're going to look at Prim's algorithm again, but this time, rather than working from a network, we're going to work from a table. So the step-by-step algorithm is exactly the same thing. We should end up with exactly the same minimum spanning tree, but we're going to work from a table. So this is the problem that we looked at in the previous video. We're going to look at exactly the same problem, but it's now set up in the form of a distance matrix. If you're not sure where these figures have come from, this is the arc AB here, for example, AE. Have a look at the network and compare. Make sure that you understand how the distance matrix works. You can see here them compared together. So A to B 3, A to B, or A to B there 3, C to D 4, C to D 4. And you'll notice on the distance matrix that all the values are repeated for this particular network because the distance AB is the same as BA. This isn't always the case with these networks, but it is the case with this one. We're going to start Prims from vertex A exactly the same as we did when we went through it with the network. The way that we do it with the table is we put a 1 above the A and we delete the whole of the row. This is because we've now connected A and we don't want to connect to a previously connected node. We then look down the column and we select the smallest of the arcs. So that's clearly the 3, and that goes from A to B. Draw the network as you go along. We now put a 2 above B, so a 2 at the top of B's column, and cross out the row for B. Again, stopping us returning to a previously connected node. Don't forget now that we have to choose from both of the connected nodes, so we look down not just B but A and B, and the smallest is the 4 here. We've got the 5, 8, 7 and 4 to choose from, so we choose the 4, and that's A to E. So again, draw it onto your network. We now put a 3 above E and cross out E's row. And we now look down all 3 of our connected nodes for the shortest, and we can see there it's the 2 at ED. Draw that onto your network. Put a 4 over D. Cross out the row for D. We now look in all 4 of the columns for the connected nodes for the smallest value, and it's the 4, which is DC. So a 5 above C, we notice we put it into the network there. Cross out the row for C, and now look in all 5 columns, where it's actually easier just to look at the unconnected node there, isn't it, and pick out the smallest value, which is EF. Obviously you wouldn't know the exact shape of this, but it actually doesn't matter, because remember, graphs are all about how you connect the points. So if you connect the points in the correct way, step by step, then as long as it shows that how they're connected, that's the important thing. And notice we put the weights on each arc as we put them on. Okay, we can put the 6 at F and delete the row just for completeness, and we can see our spanning tree of 18, and that's exactly the same result as we got when we did Prims straight from the network. Okay, here's one for you to have a go at. What I'd like you to do is to work through this, and then the quiz at the end of the video on Edpuzzle is going to ask some questions based on this network. So work it out completely in the same way as we've just done it, and then answer the questions on the quiz.